Yeah, as Ruben pointed out, so we've introduced this new REST APIs for entity management, creation, deletion, and other querying to complement the MQTT APIs that were already existing. So the MQTT APIs, even though very handy and asynchronous, had one major flaw, which was about the lack of feedback. For example, when you try to register an entity, so when you asynchronously send that message, then you don't really get any feedback unless you subscribe to some other topics and then really see whether what changes has happened in the environment. Okay, so there is no immediate synchronous feedback that was available whether the entity registration succeeded or not. So similarly for entity deregistration or deletion also, the same issue existed. So with the introduction of this HTTP APIs, so when you try to register or whenever you perform any action, say registration, deregistration, then you get immediate feedback so that you can directly act on it. Okay, so I'll be demonstrating the API set that we have currently introduced. So here I've got two devices. The top one is the main device, and the second one is the child device, which you can see in Cumulosity as well. So this is the main device and the child device. Okay. So now I'm going to have a subscriber running on the main device just to observe things that are happening. Okay. And these HTTP APIs are accessible for any clients of the main device. So I'm currently going to access it from a child device. Let's do a simple creation first. Sorry, no, 172.9.0.2. So this is the Dockerized environment. Just to save some typing, I think I'll just use my cheat sheet. Okay. And yeah. Yeah, so this is the path at which these entity store APIs exposed. So /tedge entity store, okay, and the version 1 entities. So that's the name of the collection, entities collection. And I'm going to create. We should know that so that we can see what I'm typing. So I'm going to create an entity. Okay. So when you create it using MQTT, so you send the registration messages to the this specific topic ID of that particular entity in the MQTT topic. But here you will be specifying that in the payload. So there is this special key at topic ID, and then you give device child 0. So that's the topic ID. And then you need to specify the type of that entity as well, which is child device. Okay, so let's just view the responses also properly and return that. Okay, so I'm going to send this thing. So I'm going to create a child device child 0 of child device type child device. Okay. And as you can see, you get a response, and in the response, you will have the topic ID of the entity that is created. And in the main device, you can see all these smartest messages that were published. So if you come back and inspect the child devices, so you can see that the new child device got created. Okay. So just for the sake of demonstration, let's create a few more. Let's get rid of that. Okay. So I'm just going to create a few more child devices. So child 1, child 2, okay. And to keep it interesting, so we'll create some nested hierarchy as well. So for this child 2, I will create a few nested children. So it's called child 2.0.
Alvin, sorry, can you just click hide on the share your screen tab? Yeah, thanks.
Oh, okay. So this child 2.0 would have the parent. Its parent would be our device child 2. I hope I have typed it properly. Sorry. Okay, this is like this. Okay, child 2 is created. So let's create another child for that child as well. So child 200 as the child of child 20. Okay, so I've created these entities, and let's validate those entities got created. Okay, so all the child devices are here, the first level of child devices, and for child 2, yeah, there is child 20, and for child 20, that should have child 2000. Sorry, child 200. So the entire hierarchy is created here. Okay.
Alvin,
Now,
short question for my understanding. What you're doing is you're talking to the proxy, and the proxy is converting it to MQTT. Is that correct?
No. So currently we have another. So the ThinEdge agent earlier had an HTTP server of its own, which was serving the file transfer service. So currently it has a new service called the entity store service, and you are talking to. So these requests are going to the ThinEdge agent's HTTP server, the entity store service of agent, and it is registering and maintaining an entity store at the agent level. Okay, and then the same messages. So when I try to create an via HTTP, when I create create a new entity, the same entity is published to the MQTT broker by the agent, and the mapper picks this up and creates or converts that creation into a creation at the cloud level. So our request goes to the agent. Agent publishes back to the broker, which is delivered to the mapper, and then mapper converts it to Curiosity.
But it is communicated via MQTT.
Yeah, but the local
the agent. Yeah, the agent to mapper communication happens over MQTT. So whatever these messages that you see here are the trace of the MQTT broker. So this message,
but it is created inside of Cumulosity using the MQTT channel, or is it using?
Yeah. So nothing has changed there. We're just talking purely about the local ThinEdge communication at the moment. So nothing has changed in terms of how it gets published in the clouds.
Okay.
That is exactly how it was before.
Yeah. So the cloud thing. So this specific message that you can see, that 101 child creation message. So the same smartest messages.
And this identity store is basically a shadow or something like what is in the cloud, or how can I understand that?
Yeah, a local shadow of all the entities. Yes.
All right.
So previously, we've had the entity store actually for a very long time, but it hasn't really been outwardly exposed to users. So you couldn't really check what was registered easily. You could kind of have a look on the local MQTT broker to see what was registered through the relatively new MQTT v1 kind of contract. But now we're just creating a little bit more formal way to add a ease of use layer on top, which is also in a synchronous manner, so that makes registering child devices easier. And I guess what Alvin will want to be showing is make management of nested child devices easier also to remove. But Alvin will be showing that shortly.
Okay, thank you.
Okay. So now, since we have created a set of child devices, so now, and we had to rely on the cloud to see, okay, what were the entities that were available. So this was the case earlier as well. But now we have introduced some query APIs as well, so that you can locally query the ThinEdge agent to see what all entities it is aware of. Okay. So for that, it's the same endpoint. So we just send a GET request to the same entities collection endpoint. And again, so as you can see, it will send you a REST response, an array of all the entities that is known to the ThinEdge agent or ThinEdge device. Okay, so starting from the main device, and then it has several services running on it, like the agent from a plugin, and so this is the child device from which I'm currently running these commands on, the bridge service, the mapper service, etc., and all the child devices that we create, child 0, child 1, child 2, all are children of the main directly, and then there is child 0, which is a child of child 2, and child 200, which is a child of child 20. So this way, using this query API, you get visibility into the entity store that is maintained by agent. So this is something that didn't exist earlier. So you had to subscribe to certain topics in the MQTT broker to see what's there and then detect what the state was. But now there is a direct synchronous API that you can use to query the entity store. Okay, and this query supports some additional parameters as well, so you can do further filtering. So for example, if I don't want to see the entire tree, I would just like to see the child 2 and its children. Okay? So in that case, what you can do is there is this root parameter, and you can specify the topic ID of the entity that you would like to view. And here you will see, so it's child 2, starting from the root child 2, its child, and it's for the children, so the entire child tree. So now there are a few more things. For example, if I want to see only the direct children of child 2, not the entire tree, but only the direct children, so what you can do is you can use the parent parameter, and then you will see that okay, only the direct first level of children child entities are returned. And you can combine multiple things as well. So there is, for example, I would like to see all the services of the main device. So in that case, what you can do is, let me put that. So I will say the parent is main. So I want to see the children of the main device of type service. So here I will get just the services without all the child devices. So similarly, if I change it to from child device, so then I only get the child devices. So this is the current device and child 0, child 1, and child 2. Okay, so these kinds of, so these are the three query parameters that we support currently to do additional filtering while you query your entities. Okay.
So sorry to interrupt. So this would be making a web interface quite easy, right?
Yes.
That's great.
Yeah. So it's all about, like, the motivation for this is, easier for child entities to register themselves and also make the data more accessible in a very well-defined format. Yeah. So yeah, local UIs, which, are more having a REST, can do like REST requests, and it's hard to do like an MQT client in the web. Exactly. Not impossible, but, harder. But just to make it more consumable. Yeah.
Right.
And yeah, so that's about the querying. And obviously you can inspect individual entities in detail with a simple get command as well. So for example, if I want to view the child 2, so yeah, this is a direct get request for that, and after the entities, after the resource, you need to specify the resource ID, which is the topic ID of the entity. So device child 2. Okay, yeah, and then you will get a detailed view of topic ID, parent type, all that information. Okay, so that's how the basic querying works. So now finally on to delete, and for that it would be good to see what happens in the main device at the broker level, MQTT broker level as well. That's why I have that enabled. So let's try and delete this child 2. So child 2 is the special child where it had nested children as well. So I'm going to delete that entity, child 2 entity. And in the response, you will receive all the entities that were deleted. So it was not just child 2 that was deleted, child 2, child 20, and child 200. All its nested children were also deleted. And if you look at the broker trace, so you will see that those entities were cleared. So this null message is signify clearing those entities from the broker. So these entities were cleared from the broker as well. None currently, and one note about this deletion, even though the creation of entities are propagated to the cloud currently, deletions are not propagated to the cloud yet, because it is a risky operation. So if you accidentally delete an entity locally, then if you end up deleting the cloud entity as well, then you lose all the data associated, all the measurements, alarms, everything, all the events, everything. So to avoid that risk, in the first version, we are not propagating the deletions to the cloud yet. But yeah, we have a feature planned where we will make it, we will make this deletion in such a way that you can choose whether to propagate this deletion to the cloud or not. Okay. And you may even have to explicitly specify that, okay, when I do this deletion, I would like this deletions to be synced with the cloud. So we are working on a feature like that. It may take any other shapes as well on how to propagate the device. But yeah, this is something planned, but currently in the current version, deletions are not propagated.
Because I think the main point is deletion is everyone's view of what a delete is widely different. So sometimes you maybe want to keep the entity in the cloud, but delete it locally because maybe you're decommissioning a device, but you want to keep the record in the cloud, or you want to maybe mark it as deletion. So just saying, it's not connected to ThinEdge, so it's been deleted on the ThinEdge side, and then maybe have a microservice that then looks for tagged deleted items or whatever. So we're going a little bit of the safer route to begin with. And then we want to explore, how users want to actually delete from the cloud. Is it optional, on demand, or globally configured on the ThinEdge, etc.? We'll explore those options in the next step.
Yeah.
Okay, great. Yeah, thanks, Alvin, for showing that. So we hope that's really is able to open up the information about ThinEdge. And I know deleting stuff and the nested deleting is quite difficult. So it's now a lot easier to do, especially if you're talking about services, which are a little bit more, let's say, transient in nature. Because if, containers get added and deleted, so it is kind of a little bit more flexible. Okay, so let's go to the next